The vaporizer is obviously an essential part of this anesthetic gas machine if we are using a volatile anesthetic to keep someone asleep. So I guess we could call them vaporizers because there are different types. There is essentially this variable bypass vaporizer, which is used for SIVO or ISO or halothane if you were to use those. And then the other one that exists is for desflurane. It has its own vaporizer, just because the characteristics of this gas are a little bit different. Starting with the variable bypass vaporizer, essentially it has this dial here, and you would dial in a certain percent that you want, and it would allow a certain amount of gas to bypass the vaporizer. So variable bypass versus go down through the vaporizer and pick up the SIVO in the gas form and mix. This works because SIVO is a liquid at room temperature. It's liquid and it boils at 58 degrees Celsius. Which means that at room temperature, it will be a liquid, and any liquid in an enclosed space actually does have a predictable amount of that substance in the gas form above it. The saturated vapor pressure of SIVO is going to be about 160 millimeters of mercury at room temperature. So knowing that there's this somewhat reliable concentration of SIVO in the gas phase in this container, it can send the air through and pick this up and output it. I say somewhat reliable because the vapor pressure of anything changes with temperature, so the saturated vapor pressure will increase at increased temperatures. So if your ambient temperature increased to 30 degrees Celsius, this number would be upwards of 200 instead, which means you're going to have more of these vapor particles. So maybe this would output too much gas, except that there's this measure of compensation for temperature built into this machine, this bimetallic strip. So the bimetallic strip changes its position depending on the temperature, and it will decrease the flow to the volatile when it's warmer. So because there's going to be more vapor particles in this chamber at a higher temperature, this bimetallic strip will close this off partially to decrease the amount of airflow you have, therefore picking up relatively the same amount of SIVO on the way out. I should mention that there are newer versions of these, new cassette style, which are digital. They're not going to look exactly like this inside, but they achieve the same thing. So the DES vaporizer is a little bit different because DES is troubling in that its boiling point is very close to room temperature. It's 23.5 degrees Celsius. So if you put DES in here, it'll all boil out essentially, and you'll have no liquid phase here. So instead, for DES, we heat it to 39 degrees Celsius, and we pressurize this container so there's a liquid phase still. And then there's going to be DES in the gas phase pressurized to 2 atmosphere above. It actually takes energy to go from a liquid to a gas phase. And that energy is called the latent heat of vaporization. So whenever your liquid goes from a gas, it would be cooling down this area if it wasn't for this heater. So it actually does take energy to go to the gas form, but then it's reheated immediately by this heater to hold it at this constant temperature. So it's heated to constant temp, and this avoids the cooling that happens with the heat of vaporization. So ultimately you'll have some amount of DES coming out of this part, and then here's your O2 or nitrous or air mixture coming from your flow meters, and they will mix and go towards the common gas outlet. Because I should draw that on here. This is your O2 / nitrous / air from your flow meter, and then onto the common gas outlet. This heat of vaporization that we talked about for DES is of course also happening in the SIVO vaporizer. So when the SIVO goes from the liquid to the gas phase, this temperature would drop a little bit, but then it is compensated by this bimetallic strip. The only other thing I'll mention about these vaporizers for now is what would theoretically happen at different altitudes. So if you're at sea level versus on top of a mountain, this SIVO vaporizer, the output is calibrated to the certain partial pressure. So although you're setting this SIVO vaporizer dial to a certain percent output that you're looking for, really what it's telling the machine to do is to output a certain partial pressure. So regardless of what altitude you're at, when you set your vaporizer to 2%, it will output the partial pressure of what would be 2% SIVO at sea level. DES vaporizers, on the other hand, output the set percentage, or they're calibrated to percent. So whether you are at sea level or you are on top of a mountain, you set this dial to 2%, it will, or I guess you would set it to 6% if you're using DES, which would be more reasonable. It is always going to be outputting 6%, which means that your partial pressure is variable with altitude. And that's just somewhat problematic because, of course, it is the partial pressure of the anesthetic gas that has its effect, and not what percent it is compared to the rest of the air. So if you hiked your DES fluorine vaporizer up a mountain where the barometric pressure is lower, you would actually need to set the percentage of the vaporizer higher so that it still outputs a partial pressure that's appropriate to keep the patient asleep. So after running through the flow meter and the vaporizer, your gases will go to your common gas outlet, which then goes to the fresh gas flow of the circle system. We'll talk about that in the next video. Just to clarify that the common gas outlet shown here is the same gases that are entering through the fresh gas flow in the next video. I want to re-emphasize the fact that this O2 flush valve pathway that we take here is not elegant, but it is very effective at sending oxygen through the system. Some words of caution about this is that, again, it delivers very high pressures. So it delivers the O2 at line pressure, which is 45 to 50 psi. 45 to 50 psi. And to put that into perspective, 14 psi is 1 atmosphere. So we're delivering 3 to 4 times atmosphere when we press this button. And this can equate to flows of about 1 liter per second. And just imagine the damage this would cause to somebody's lungs if you were actually giving them 1 liter every second into their lungs if that button is depressed. The second issue with this is that it dilutes your inhaled anesthetic gas mixture. Dilutes inhaled anesthetic. Now you spent all of this time precisely titrating your gases through the flow meters to get a certain percentage of oxygen, air, and nitrous, and then getting a certain percentage of volatile from your vaporizer and sending that to your common gas outlet here. But when you flush through this O2 flush valve, you're just delivering 100% oxygen. So you will no longer be sending concentration of gas that is an anesthetic to the patient, and that is counterproductive. So now that we've shown the gas mixture and sending it to the common gas outlet, next video we'll talk about the circle system and how it's actually delivered to the patient.